Hello everyone, I'm back after it's June 6th, so I don't even want to talk about it. Anyways, the problem we're looking at today is USACO 2023 US Open Contest Silver. So yeah, I'm in gold, I'm preparing for platinum, and I'm doing a silver problem review. Anyways, silver problem to a field day. I'm still hoping silver basic knowledge can help me somehow, or it's just because I got this huge storage of silver problems I solved and haven't put a video review over. Anyways, the problem statement is actually really easy, and this is a very interesting problem, I will say. I still remember the excitement when I solved it because it's just a great problem. And I mean, there's a lot of great problems out there, but this is one of those great problems where I actually solved it by myself. So yeah, that's something special about it. Anyways, the problem statement is really easy. You have a string of G and H, and now you're trying to find, for each string, you're trying to find the string with the maximum difference from this current one. So say you're looking at this one, GH, GGH, you're trying to find the string out of these three that has the most digits different from GH, GGH, which in this case, looking at it, it should be this one, right? Because all 5 digits are different. G different from H, H from G, and then etc. All 5 digits are different, so it's 5, and then respectively you have that, and then this one has the most digit difference, just the first one. Okay. However, n is 10 to the where n is 10 to the 5th power. However, c is very small. N is big, but c is small, which means that even though you can have a lot of strings, there can at most be 18 digits to each string. So now you can pause the video and try to solve the problem yourself. Okay, so I mean, it's in US Open and also 2023, so I would say for silver, this is pretty good difficulty. At least for me, I think it was more difficult than both the other two because I solved the other two before I did this one when I mocked the contest. I got a perfect score on that on the mock, by the way. Okay. Anyways, this problem is, first of all, the first thing that I thought of when I looked at this was that since there's only 2 type of letters and we're asking for max difference, we can kind of, if you can see it, kind of convert it into like a XOR kind of thing. So for each essentially for each of the original string, we have GH, say GH, just like the string they gave us at the first sample. We can just kind of convert that into 1 0 1 1 0, if you can see the yellow, right? So then for the last string where it's HG, then it'll just be 0 1 0 0 1. So then the number of digits different will just be those two, but XOR, which is this symbol in C++, as we know. So now the problem has been converted into, I guess, more mathematical form. But then we still really doesn't have any idea on solving it because n is 10 to the 5th power. So if we just iterate through every other string, it's going to be obviously way too slow. So how do we do that? Well, right now there's really only one, I would call it, weakness to this problem, is that C is 18. So there must be something we can do about it. So here's when you have to do a lot of musical problems, and then you can realize that 18 is not any regular value. 18 is USACO's range for state compression DP, which is the word I used for this back in December 31st, which is when I did it, December 31st of 2024, obviously. And then right now I learned that my so-called state compression DP is actually called bit mask DP. So it's basically when you have a giant number as in your state of the DP, and then this number, when you change it into binary, each 0 and 1 represent a situation in which one of the terms in or whatever. But you guys know all about bit mask DP already. Anyways, 18 is the range that USACO usually use if you're gonna have to use state compression DP. See, like the term that you're going to compress is usually 18. So then, well, how are we supposed to do a state compression DP on this problem, or bit mask? I guess I'll call it bit mask DP now. Okay, how are we supposed to do a bit mask DP on this problem? The only state that at least I could think of in this problem was fi equals the number with the least digit different from I. Because if you think about it, if we do the I with the most digit different, it's gonna be kind of difficult to do, right? But with the least digit different, you can just the transition is really easy. You just change one digit. Say you flip 1 0 to 1, or you flip a 1 to 0, and then instead of I, you now get a J. So if J already exists in the input as one of the strings, great. So then Fi is just J. Otherwise, Fi is just Fj. And then for each of the Fj, you find the one with the minimum digit different from I. So that feels about right. And then also the least digit different, you can just transform that into the most digit different pretty easily by literally just flipping every single digit. So now we just have one problem left because we don't know what order of the transition we should do. Usually the order we do is say from the least number of ones to the most number of ones, which obviously would not work here. Or if we just go from least to most in terms of value, that really wouldn't work either. So now we need a unique order of transition for this DP. So back in December 31st when I did this, as you can see here, I remember recently learning a method called Q-aided DP transfer or Q-optimized DP transfer, which I didn't even really understand by then, which, by the way, it's been 6 months and I still does not understand at all what Q-optimized DP was. But back then, I think it's probably something like a BFS kind of, because, well, BFS used a Q. So basically my idea back then was to basically push each of the state, like the input state, the input strings, each of the input strings as a state into a queue. And then each time you take out the top of the queue and then you transfer it and then you put it back and then take out the top of the queue again and then you transfer it by changing a digit and like say the J that you got from changing this I that you just took out of the queue, the J that you got, you put the J back into the queue and you do this over and over and over until you're done with every single input string. So that felt about right. So I'm just gonna go ahead and show you my code here. Gosh, it's been a while since I did any problem reviews, and these code looks so old. Back then was when I still used the giant head file. The problem that I did today, I already kind of changed my style here, so my new code I don't have that giant chunk of default source for my head file, should I call it? Because it really isn't. There's a bunch of just random default source. Anyways, my code here, the Q-aided DP transfer does look a lot like a BFS. So we have a queue here, and if it's empty, obviously we break. And then each time we take out the front of the queue, which is the first one that we put in, and then we pop it out so we don't take it out again. And then for each of the digits, which is less than C, we try to change it. And if the changed one has not, by the way, if f is -1, it means the closest has not been found yet. It's not been transferred. So if x is -1, that means the next is the closest existing. That means we can transfer the next. Because remember, if this thing is in the queue, then the closest have already been found. So that's why we push all the input string into the queue first, because we know the closest to the input string's already been found. It's just itself, right? So if the one that we changed one digit is closest has not been found, then we always change the value, and otherwise we don't. Why? Because if the value has already been found before this term, just like BFS, that means this point's basically been reached in a less number of steps than this. So that's why we always change it the first time we reach it. So f next is changed now into f now, and then you just push next into the queue so we can transfer other stuff. And now we just find the answer for the what's the term for that? The negative. It's not negative. You just flip every single digit. I don't know what that term is called, but just find the f value of after flipping every single digit, and then use the bitwise XOR, just like we transferred it. We transferred the problem at the beginning, right? Use a bitwise XOR to find the value. Then all the digits are different, and then built-in pop count is just a function that counts number of 1 in the value, which number of 1 here is just going to be the number of digits that are different from AI, and the one that we found was the most different from AI, which want is just flipping AI, and it's just pretty easy like that. Hey, AI. Anyways, then answer is just the number of digits that are 1, and then you output answer. Anyways, this is a very fun problem, I would say. First of all, you have to notice that you can transform the whole thing into just ones and zeros, and the operation is just a bitwise XOR. But then I would say for me, the biggest breakthrough is noticing that 18 is the range of USACO for a not state compression bitmask DP. There's a word, bitmask DP. So then you try to use a bitmask DP, and then notice that you have to use the least digit difference instead of the most digit difference, because that's much easier to do. And then you can just flip at the end to find the most digit difference, and then notice that regular order of transition is not going to work in this case. So use kind of like a BFS, and then you solve the problem. very fun, very much fun. I think it took me like pretty long, longer than the other two problems, like 1.5 hours. But yeah, anyways, that's it for this video. Thank you for watching, and I'll see you tomorrow. I'll actually start doing videos every single day now, so I'll actually see you tomorrow. Hopefully, most likely, maybe not. Okay, so that was the problem review. However, this is an actual video now. Like, we're actually resuming in the January grind mode where we post a video every single day, and there's a grind report for it. So we're actually having a grind report here. So that was it for the problem review section. And if you're just here to look at a solution for the 2023 US Open Contest Silver Problem 2 Field Day, then you can go ahead and click out this video. Otherwise, here's the grind report. So basically, today I'm finally actually resuming into my summer grind now, and my goal is just to recreate January. So this is the problem I solved today, which, as you can see, I'm rusty around the edges, and this tiny little greedy took me, I don't know, 30 minutes. It's concerningly long, but yeah. And also, I didn't even come up with the like most difficult part, like the first thinking and property part. I just wrote the code, and it took me like 30 minutes. Anyways, I'm rusty around the edges, but this problem is actually really fun. Is here we go. Nope, nope. Here, wait, nope. Okay, this problem. I haven't solved the problem on logo in a while as well. Basically, you have a wait. Why am I translating to Chinese? Hold on. Translate. Okay, so basically, you have a complete graph in which every pair of points have an edge between them, and then every single edge is bidirected, right? And then you just put direction to the edges, and you try to make the out degree of the ith node be within the range of Li to Ri. So it's a very interesting problem, and I'll save the actual problem review over it for later. But anyways, I'm just saying I'm actually back. Like, I'm back on Logu, I'm back on USACO, and I'm back on YouTube for you guys. So I'm gonna be doing problem reviews and grind reports every single day now, and I don't know, maybe by some miracle, if another US Open difficulty gold happen again this season, I might actually make platinum in 1 year, and that'll be a miracle. But yeah, I'm back. Okay, thank you guys. If you're still watching this video, that means you probably subscribed. If you haven't, go subscribe. Anyways, thank you, and I'll see you tomorrow, hopefully.